Today we're working on chord segments. So not only do circles tell us something about the degree measure of arcs and angles, they can also tell us about the lengths of segments that are associated with lines intersecting the circle. So the first type of segment we're going to talk about are chord segments. I'm going to page 145. And our objective today is to determine segment lengths in and around circles. So since we're talking about a chord segment today, let's draw a diagram with two intersecting chords. Okay. So in this diagram, our theorem will be that if two chords intersect, then AE times CE, so a part of one chord times the other part of that same chord, will be equal to BE times DE, which is the part of another chord times the other part of that chord. And I remember this as part times part equals part times part. So why is this true? Well, whenever I see two things being multiplied together like this, I know that this is a cross product. Okay? When I'm thinking about cross products, I should be thinking about proportions. When I'm thinking about proportions, I should be thinking about similar triangles. So there's actually a pair of similar triangles in here that makes this theorem true. And we'll talk about that proof in a little while. But let's go through a couple of examples first. Okay? So, let's say that AE is 3, EC is 8, and DE is 4. Let's find EB. So I would do 3 times 8, that's the part times the part, equals 4 times x, because I don't know what EB is. So 3 times 8 is 24, and 4 times x is 4x. I divide both sides by 4, and I get x is 6. And that's pretty straightforward and easy, but let's make it a little bit more difficult. Okay, let's say I had A, B, C, D, E. And I had DE being 5 and EB being 6 and AE is X and EC is X plus 7. I wanted to find X. So again, I'd set up that same cross product. Okay, so 5 times 6, that's my part times my part, equals X times X plus 7. So 5 times 6 is 30. X times X plus 7. When I distribute, I get X squared plus 7X. All right, now this is not a linear function. This is a quadratic because I see an X squared. So if I see a quadratic, I want to get it equal to 0. So to get it to equal to 0, right now it's currently equal to 30. So to get 30 down to 0, I need to subtract 30 from both sides. 7x and 30 are not like terms. So I'm just going to write it out. Now I need to factor. So I want to find what adds to 7 and multiplies to negative 30. So what multiplies to negative 30 and adds to 7 is x minus 10, or x plus 10, excuse me, and x minus 3. 10 times negative 3 is negative 30. 10 plus negative 3 is positive 7. I set each factor equal to 0. So x is negative 10 and x is 3. I'm going to have to reject one of these because x is a length, and lengths can't be negative. So x is 3. So let's go back to this proof, and I'm not going to actually write it out, but we'll leave that for the beginning of class tomorrow, on Monday that is. Let's go back to this proof. A, B, C, D. And I need to prove, this is not a very good chord, E. I need to prove that AE times EC equals BE times ED. So I see a cross product. If I see a cross product, I need a proportion. And if I'm working with a proportion, I need to prove similar triangles. So they don't have similar triangles in this diagram. So I kind of have to figure out where those similar triangles should be. I'm going to connect BC and AD to make similar triangles. Okay? So as I'm looking at this, I'm thinking about similar triangles. How do I prove triangles similar? Well, there are 3 ways to prove triangles similar. Angle, angle, side, angle, side, or side, side, side. And whenever I'm using sides in similar triangle proofs, they need to be in proportion. Since I don't know anything about the lengths of these sides, I can't use either of these methods. So I have to talk about my angles. So as I'm investigating this diagram, I see that there are a pair of vertical angles that are congruent. So as I kind of figure this out, I've got my 1A, I need to find my other pair of angles that are congruent. Well, this is where I kind of want you guys to figure this out. So when we come back on Monday, I want you to tell me what is the other pair of angles that are congruent and why. I'd like to remind you that AD and BC are not parallel lines. Okay, I just drew them in. I don't know anything about their parallelism. And I'll start the proof. Okay. But I'll leave some blank spaces, and I think that you need to be able to fill those in. So my givens are that AC and DB are intersecting chords. And I knew right off the bat about these vertical angles. Okay, I know that I'm going to end with talking about a cross product. I don't know what step that is. And if I need a cross product, I need to be saying that sides are in proportion. Corresponding of similar triangles are in proportion. but I'm going to leave you to figure out the proportion that is in the statement. And if I'm talking about corresponding sides of similar triangles being in proportion, I need to tell that my triangles are similar. So it'll be angle, angle, similarity. Okay, and these are my last 3 steps, so you need to provide me with 2 statements, and you have to come up with a statement and a reason to prove another angle similar. This will be our warm-up on Monday, so make sure you have an idea of what goes in here and an idea of what these 2 statements should be. And that is all.